Well, thank you, everyone. Today not only marks the 32nd edition of the Workboat Association AGM, but it also the first event in our new series of Get Set for Workboat 2050, which is now in its 6th year. These events have, for those 6 years, been brought to you by the wonderful partnership of the Workboat Association, along with the Seawork team at Mercator Media. This series of Get Set Workboat 2050 is supported by the Society of Maritime Industries and also the UK Harbour Masters Association. Now, last year at our AGM, when I was providing my slides in our conversation, I informed the membership that one of the most talked about topics of the year was both remotely operated but autonomous vessels. Now, by removing personnel on board vessels, we also removed the need for a lot of the typical vessel's physical structure and its equipment. But are we removing personnel or just moving their place of work? Remotely operated vessels are becoming the new norm of the industry, particularly in offshore contracting and in the surveying sector. And on those repetitive and often mundane tasks, someone could say, you could say that there's currently a kind of robot lawnmower or vacuum cleaner of the sea approach. But is this actually the case? We have a number of experts today to discuss the reality of operating, financing, regulating, chartering and working alongside remotely operated vessels and vessels with a level of autonomy on board. And the panel are going to discuss themes such as integration, range, manoeuvrability, benefits, negatives, reliability, and often the reality, which can sometimes be regulatory red tape or expectational differences. Do unmanned vessels pose a threat to the livelihood of the conventional small vessel operator? Today's speakers are hopefully going to let us know. Before we get underway, there's a couple of last details I just want to point out. This session is being recorded and it will be made public following this event. So take a look on the Seawork website to find that. And please share the links with your colleagues or friends or anyone that's missed the event. And we do promote comments. So the second part of this event is going to be asking you, the audience, for your comments, and I'll be walking around with the microphone to help with those questions. But I don't want to stop this any further. You've heard enough from me. And so I'm going to hand over to Get Set's resident moderator, Andy Page of Chartwell Marine.
Thanks very much, Kerry, and good afternoon, everyone. Welcome to Get Set 2050, Series 6, Session 1. Today, as Kerry expressed, our theme is autonomous and remote-operated vessels, with the specific subject being operational scaling and regulatory alignment. So today we've got a panel of 4 speakers, some covering regulation, some covering application of USV, and then Jason is here as a vessel owner and operator to try and talk about how he's incorporated some levels of autonomy within his operation. So our first speaker this afternoon is Dr. Esme Flegg. She is an innovative technology lead in the code vessel team at the Maritime Coast Guard Agency. She specializes in developing regulation and creative solutions for small commercial vessels, utilizing innovative technologies such as remotely operated and automated systems. She also covers alternative fuels and propulsion systems, so there may be some crossover in our discussions this afternoon. Dr. Flegg has worked at the Maritime Coast Guard Agency since 2020, drawing on her unique skills and expertise, which she honed whilst undertaking a dual-disciplinary PhD on maritime engineering and maritime law. So Esme, please, looking forward to you and your presentation. Thank you.
Thank you, Andy, and also thank you to the Seawork and Workboat Association team for the invite to speak today. It's lovely to be able to come up and join you. So, surprise, surprise, I'm the Maritime Coast Guard Agency representative, so I'll be talking regulation. So I'll be primarily focusing on the under-24 sector, but also giving a bit of context of what's happening on the international stage as well, because some of you may find that of personal or general interest. So just to give an overview of the topics I'm going to touch on today, I'll start off by going through what certification and declaration routes are available for workboats, which are using autonomous or automated technology. Then I'll also give a high-level overview of what work's being undertaken in regard to training and certification pathways for remote operators. And then I'll shift the focus to the wider view, looking at what's happening on the international stage, what's currently underway, and what we foresee in the coming years. And to do that, I'll be looking at the IMO Mass Code and the excellent work that's going on there at the moment, and also touching on the North Sea Memorandum of Understanding. So I'm going to start with the smallest of vessels and then slowly increase in size. So that's my logic here. So there are a number of pathways available at present for workboats under 24 metres. And last year, in 2024, the MCA, we published 2 marine guidance notes, which each include a general exemption. And these general exemptions enable eligible vessels to operate without certification issued by either the MCA or its delegates, its certifying authorities. So firstly, we have MGN 702. And this sets out a general exemption for maritime autonomous surface ships, MASS, of less than 2.5 metres in length overall. And when I'm saying MASS here, just to clarify for some in the room, I'm talking about a vessel which has any remotely operated or automated mode of operation. With this general exemption, I do caveat that a number of regulations such as coal regs would still need to be complied with for the vessel to the extent that it applies. Obviously, when you have a smaller vessel, some of the requirements naturally fall out. And to go through the process of marking their vessel as declared against the general exemption, the vessel's owner or operator has to submit some basic information to the code vessel team so we can manage it on our internal databases, and it's useful information such as the name of the vessel and her date of build. And as of today, we currently have 32 vessels declared against the general exemption for MGN 702. The second general exemption, which we published at the tail end of last year, can be found in MGN 705. Now, this isn't for all MASS, this is a narrower window. This is purely for remotely operated unmanned vessels, which are of between 2.5 to less than 4.5 metres in length overall. And what do I mean by an RAUV? I'm talking about a vessel that has no persons on board. There's no crew, there's no passengers, there's no industrial personnel. And the vessel itself is operated from a location which is remote to the vessel itself. So it has a remote operations centre. Like MGN 702, there are a number of regulations that still apply and still need to be complied with. And there's a little bit more work for the vessel owner or operator to get to the declaration stage. They need to fill out a self-declaration form, and that includes an assessment of, basically a risk assessment of how they've minimised everything to a LARP. And that would also need to be submitted to the code vessel team again. And to date, we currently have 4 vessels which are using this general exemption. And once a vessel owner or operator submits information to declare against either of these general exemptions, the code vessel team would then send an acknowledgement to confirm to them that the vessel is registered on their database and they're good to go. So the third pathway will be the one that's of most familiarity to you in the room, and that is Workboat Code Edition 3. And there are 2 new annexes to the Workboat Code. You've got Annex 1, which sets out requirements for battery electric or battery hybrid propulsion systems, and we are seeing that method of power as particularly useful for the remotely operated unmanned vessel sector. We are generally seeing that people are choosing to go down the electrification route, even if it is in a hybrid stance, rather than sticking with traditional petrol or diesel setups. And then we also have Annex 2 of the Workboat Code. That sets out the additional requirements to be complied with if your vessel is a remotely operated unmanned vessel. Now, I often get the same question from people. What if I can't comply with the entirety of the code? Well, we have a solution for that. So we have a process where the vessel owner or operator can submit a request for equivalence where there's an area of non-compliance. So that vessel owner or operator should get in touch with their chosen certifying authority to say, I have this proposed alternative I wish to suggest. And then if the certifying authority is satisfied, they will then submit an MSF 1261 to the Maritime and Coast Guard Agency, and that will then be reviewed. And if agreed, there will then be an approval issued, which will be sent back to the certifying authority, and that will then be kept on the vessel's file for the life of the vessel. However, if you're unable to provide something that's equivalent, there is also the potential of going down an exemption route instead. It's the exact same process of you propose what the challenge is to your certifying authority. If they're content, it goes through the same MSF 1261 form, and there's an administration review, and if satisfied, an approval would end up being put on the vessel's record. The fourth available pathway is not just for the under-24 market and also not just for autonomous vessels. This is MGN 664. So this guidance sets out the case-by-case certification process for vessels wishing to use innovative technology. And I mean that term in the broadest sense. So we could be talking vessels using perhaps ammonia or ethanol, a vessel which wishes to try and use a Degree 4 setup for its autonomous operations, or it might just have some other smart technology that isn't considered within the current regulatory framework. So those are the overview points for the certification declaration pathways, but we're also at the moment undertaking some significant package of work relating to training and certification of remote operators. So to give you a bit of grounding of where we already are for the small vessel sector, we already have MIN 642, which is the Engineer Officer Small Vessel Certificate of Competency Guidance. And this note sets out guidance regarding the implementation of alternative training requirements which are equivalent to that of STCW. We also have MSN 1865, which then sets out applicable training elements under Chapter 4 of STCW. But at the tail end of last year, we published MGN 703. Now, this sets out information relating to the training and the competence of remote operators working with remotely operated unmanned vessels, which are specifically certificated to Workboat Code Edition 3. And then in June this year, the MCA published the Voluntary Remote Operator Training and Certification Pilot Framework. This sets out proposed generic training and certification for remote operators who are undertaking watchkeeping duties. So moving on to the international stage, I thought it would be a good idea to give you all an update, a good flavour of what's happening at the IMO en masse. So the International Code of Safety for Maritime Surface Ships, known as the MASS Code, is a rapid package of work being undertaken by the International Maritime Organisation's MSC committee. And the code applies to cargo ships which are more than 500 GT and which have functions that enable either autonomous or remote operations. Now, the important thing to note is that the MASS code is supplementary to any applied-based instruments, such as SOLAS and COLREGs. So it only addresses MASS functions that are not already covered in existing instruments. It's goals-based, it's technology-neutral, but we are working to a rather challenging timescale on this front. So in May next year, the non-mandatory code will be finalised and adopted. And then the framework will be developed for a 2-year experience building phase before in 2028, and that really on a regulatory timescale is not far ahead at all. The intention is to begin developing the mandatory code, followed by adoption in 2030 and entering into force in 2032. So there is a lot of fast-paced and very exciting work undertaken on that stage at the moment. And then lastly, I wanted to give you an update of another exciting collaboration that is underway, and that is the North Sea Memorandum of Understanding. Now, this was initially signed during London International Shipping Week in 2023 between the UK, Belgium, and Denmark. Later in 2023, the Netherlands joined. Last year, Norway joined. And this year, France and Germany have also joined to complete the current group. At present, there are no plans to further extend the MOU, but the purpose is to facilitate collaboration between the signatories in order to facilitate at-sea operations of MASS in the North Sea and to help develop best practice on a domestic scale. The meetings we have also support the preparation for international sessions, such as the work in developing the IMO MASS code. And the MOU itself has a number of key values and benefits. For example, it facilitates the following. It provides early engagement and communication about international trials, tests, and operations with other signatories involved in the programme. It provides clarity and transparency regarding local and domestic requirements, including operational requirements and certification, prior to taking place of international operations of MASS. And we also participate in biannual and post-operational meetings to review regulatory developments and issues regarding MASS. And the most recent technical meetings have focused on deepening the understanding of barriers and limitations within respective domestic legislation that is affecting MASS operations in different signatories' waters, and the views and research that each signatory is undertaking regarding the location of remote operation centres. Last month, the MCA successfully hosted this year's North Sea MOU Symposium, and the work with the other signatories continues to go well. And some signatories are currently looking at using Annex 2 of the Workboat Code to aid their own regulatory developments. So, as an agency, we are very keen to see how the collaboration of the signatories continues to progress over the coming months and years. So I'd just like to say thank you very much for your time, and I look forward to questions and discussion later.
Thank you very much, Esme. Before we go on to our next speaker, I just wondered if you could just give us a flavour of context on the number of vessels, perhaps compared to other North Sea MOU members. So there's 32 MGN 702 vessels, that's under 2.5 metre. 4 in the MGN 705, sorry, which is the 2.5 to 4.5. How many do we have under the Workboat Code at the moment?
So under the Workboat Code at the moment, I'm going to have to estimate, as of last month under Workboat Code Edition 3, I think it was around 260 vessels.
As uncrewed vessels?
No, not as uncrewed vessels.
Okay.
In terms of Workboat Code Edition 3 uncrewed vessels, we have issued certification for 2 vessels.
2 vessels. Okay.
Yes, but we have a number of other vessels which are getting close to the certification stage.
So we've got 38 vessels which are uncrewed under UK certification. How does that compare, do you know, to other North Sea MOU members? And as such, do we have much influence over the development of those criteria?
So I don't have numbers for the other North Sea MOU partners, but in terms of where we are both in terms of the regulation and also in terms of the general numbers of vessels. Some nations we are ahead of, some we are fairly close to, but it varies because each signatory has their own domestic legislation, and for each country, when that legislation was drafted, it wasn't drafted with autonomous vessels in mind. It wasn't, imagining with their crystal ball what was going to come down the line X decades later. So every nation is having their own unique challenges to work out how to weave the legislation for autonomous vessels into their current legislative structure.
Okay, complex answer.
Yes, unfortunately.
Yeah, because it's naturally these most people that are running these vessels are using them internationally. Please do work hard to influence as much as you can and implement the UK criteria. Thank you. Mm-hmm. Okay, so hopefully our next speaker, Simon, can give us some application experience, actually designing, building and operating these vessels. So Simon is the founder of USV Group. He brings a wealth of hands-on maritime experience to the forefront of uncrewed surface vessel innovation. Simon served as a master on board workboats, including tugs and barges, before transitioning to research vessels for companies such as MMT and Fugro. This real-world experience underpins a USV adoption ethos rooted in practicality and operability. With global operational experience spanning in the UK, US, Europe and Asia, Simon has cultivated robust practice for tackling integration challenges from requisition to regulation. Thanks very much, Simon.
Thank you. Good afternoon, everyone. Thanks very much. Thank you to the sponsors and Kerry for having me. It's a pleasure to be here and being able to talk to you. So, this afternoon I'm going to tell you a little bit about me, which I can skip now, thanks to the great introduction. And then I'll tell you a bit about the USV Group, what it really is, what it tries to achieve. And then we'll look at some of the challenges in the industry and then set those against a little case study just to see how those challenges really stack up in the real world operational environment. Let's get cracking. There's the about me bit. The first thing you need to know about me is that that's actually not me in the picture. I took the picture, but as Andy said, I came from actually workboats and then moved into survey vessels, worked for Fugro, came ashore, and then USV started popping up. So I liked that, I enjoyed that, and I made the voluntary transition to go from workboats to USVs. I wasn't forced, it wasn't like my company said, we're automating your role. I actually chose to do it. And in the years working with USVs for companies like Solmara, an offshore survey company, and then more latterly Rovco before its demise, I kept seeing the same problems cropping up, and I thought, well, I think we can do something about this. So I started the USV Group. So the USV Group's trying to help bolster the industry by making USVs more accessible and trusted. Okay, it's giving industry enough confidence to actually want to invest or want to move towards it. There are a number of challenges in that integration process. So, take out the developing a USV bit, but let's say you just want to integrate a USV into your existing business line. There's like a staircase of challenges that you have to go up. And every company has strengths and weaknesses in that kind of journey and upon that staircase. So the USV Group tries to identify those gaps and support them and fill them. And then that helps the business have a slightly better experience than those early USV adopters that went through a lot of pain through that process. And as you can see, yeah, I've got some fantastic clients and partners that I'm already working with. So yeah, I started in April, really, really proud of that, completely organic business that started from nothing. So yeah, really, really pleased. So what are some of those challenges that I'm banging on about? Well, operational complexity is the first one. So if we take out the smaller USVs, the ones that you can deploy from a slipway or throw off the side of a boat, and we focus on that slightly bigger style, you know, the over the horizon we call it, that's operating a USV through SATCOMs from a significant distance, more meaningful USVs. This is complicated, and the regulation is one of the greatest complications actually. But I'm going to park regulation. We've heard a bit about that. And we're going to come back to it undoubtedly. But I will say a bit about inflated expectations. So what do I mean by that? Well, here's an example. I've got an autonomous kettle, okay? I flick a switch, and then later on it switches itself off. Is that autonomy? No. Yes, is it? I don't know. You be the judge, right? But there's this kind of inflated kind of expectation of what technology brings, what autonomy really is. Where is the line between remote operation and autonomy? If we look at Workboat Code Annex 2, it's called the Workboat Code Annex 2 for remotely operated uncrewed vessels, not autonomous vessels. There is a difference, okay? So what we're being told when we go to things like ocean business and oceanology, you'll see 20 different USVs. Everyone says theirs is the best. Does that mean 19 of them are lying? Well, not necessarily. It just means some are better at certain tasks than others. And knowing the difference and the limitations is really important, especially if you want to invest. And that leads you on to cost. Okay, ultimately, it's got to add up. Okay, and in the early days, it generally doesn't because we're trying and failing. So the first few years at Solmara, we tried and we failed many, many times. But we learned an awful lot through that, and that's the pathway to success with new tech. So it's not always great to be going first. Ultimately, if these kind of bullet points aren't observed, what can happen is people spend a lot of money, they invest in a piece of technology they don't quite necessarily understand, and then they go out and they fail operationally. And what happens then is that your end clients, so if it's a wind farm target market, for example, okay, the last thing you want is a wind farm operator going, hey, well, that USV really sucked, didn't it? We're not going to do that anymore, because then the operators below them and then the innovators, so we've got John next from Mercure, it disrupts the reputation for USV for all of those. So in the early days, it's absolutely vital that we try and get it right operationally. Mini case study. So here's a USV, it's called a Drix. It's not a submarine, okay, it's a surface USV. It's 8 meters long. There's nothing that fancy about it, really. It's got a traditional 4-cylinder diesel engine, okay? So it runs a Nani. It's a Kubota block, so it's really reliable. It's normally aspirated. It goes through a ZF gearbox to a shaft to a 3-bladed prop. It can do about 12 knots. It's got 250 litres of fuel. It can stay at sea for 5 days if you bring the speed down and run it economically. That's 250 litres for 5 days. So that's the advantage, right, that this kind of equipment can bring, okay? And it's used for survey operations, so mapping the seabed. Really cool piece of kit, really stable in the sea, wave-piercing bow, very stable. Yeah, really cool, really like operating it. You can use it line of sight or over the horizon through SATCOMs. So I've driven these kind of USVs kind of from Glasgow when they've been in Taiwan or the Gulf of Mexico. It can be done. The particular project we're going to look at quickly is to do with a project taken out in Germany. I've done a few projects there. I can't be too specific because of the confidentiality agreements with the clients at the time, but I've managed to tweak it enough to be generic enough for you. So the first thing we need to note, it's already been noted, I think, earlier on by the Workboat Association, is international operations. So it's one thing to take your boat to a company like Germany. It's quite another when you say the word uncrewed. So there's that to navigate. So here we are. Let's have a look. So how do we do that? Once you've got your asset into a country, you have to think about every step of the operational journey to get to your site. Just look at the stakeholders that we've got here. Okay, so we're starting in German territory. We've got to get the right berthing, the right lifting, the right support arrangements in country. We've then got to get out through a lock, so we need the local permissions, and they have to tell us what their requirements are for uncrewed to go through their lock. Once we're out the lock, we're into Dutch jurisdiction, so that's EMS traffic. So that's another layer of regulation that needs to be addressed. Once we get clear of that pilotage route, we're then into open water before we're then back to German jurisdiction. So we're crossing a TSS with a USV, okay, back to the Germans. When we're north of that area, we're then into a very heavily populated area of energy infrastructure. So you've got wind farms, you've got jack-up ships, you've got pipelines, you've got all sorts of stuff going on. It's owned by the Germans, it's owned by the Danish, it's owned by the Dutch. All of these stakeholders, when it comes to SimOps, is really quite a complicated affair. So you can imagine the kind of planning that it takes to get a USV from A to B in that kind of environment. Just to add another layer of complexity, we've then got a Scandinavian company chartering a French company that then charters me. So I'm there in the middle trying to make it all happen. And you can imagine with a British accent, I'm not sure how you are with current affairs in Europe right now, but it's actually adds another layer of complication again. So yeah, there you go. So operational complexity, the regulation, and inflated expectation. So imagine we break down halfway across the TSS. Okay, look at how much of a spotlight is on USV at the moment. Okay, if something goes wrong, everyone's going to know about it. And that's really damaging for the entire industry when that happens. So my point is, operational execution is absolutely vital. Lastly, cost. Okay, yes, it's high. Yes, we have to have support vessels. So in the early days, the wind farm operators are allowing this to happen. They're footing the bill because they understand that it's a step change process. How do we get involved? You know, so I made the transition as an operator. Robots are not taking over the seas. Regulation is doing a good job of keeping the brakes on a little bit. So we've got time to adapt. And I think it's going to be a choice. So mariners are still going to be responsible for USVs. People are going to have the choice to make the transition. Maybe you don't want to go to sea anymore. Maybe like me, you wanted to stay at home and have a family. Maybe ex-servicemen want to get involved, okay? People with injuries that can no longer go to sea. It opens doors for lots of types of people. With that comes the ability to then upskill a little bit. So you're learning about communication systems in more detail, cybersecurity and data management. And then there are new jobs entirely coming along. So in the development space, all the data managers, so all the developers, ROC operators. It's big, you know. I don't think it's going to, I think my bottom line is that, you know, the USVs are not going to replace people. It's going to unlock the potential to do things differently for those that want to be involved. No one's going to get forced into this. So yeah, there we go. A quick insight to the complicated world of USV for you. So thank you very much for listening. I've been Simon. I'll see you at the bar.
Thanks very much, Simon. Okay, so thanks, John. John is going to be our next speaker. So John comes with 15 years' experience in maritime operations, defence capability development, and autonomous systems. John Hunnebel is a seasoned leader driving innovation in the marine technology sector. He is Chief Product Officer and Head of Marine Operations at Akira Ocean. He leads the design, delivery, and deployment of sustainable autonomous surface vessels, shaping the future of ocean monitoring and defence applications. So over to you when you're ready, John.
Thank you very much. Just setting my little widget so I know when to get off. Thanks very much. Thanks for having me. Good to be here. So I was asked to turn up. We've been a member of the Workboat Association now for about 16 months and give a bit of a case study. We are a UK startup, so we're a little company based in Plymouth, There are 25 of us. Plymouth, designated recently, is the UK's National Centre for Marine Autonomy, if you didn't know that. And within Plymouth, there is one nub, one real techie hub where there's like a little gaggle of us all together, and us and Marine AI, both members of the Workboat Association. I saw them joining this year as well. That really is the heart of the centre of marine autonomy in the UK. I'd say it's Turnchapel Wharf, and that's where we're based. There's a reason we're down there. It's the ecosystem, but it's the permissive environment to get out there and test and evaluate our kit. It's easier to do that with a new boat when you've got people on board and it's conventional propulsion and you can fix it if it goes wrong. Doing those initial harbour and sea trials when you've got nobody on board and it's a 25.5-ton robot sea monster like this, it's a bit trickier. So you need those local harbour authorities' permissions to do that before you get to the point where you're certified and you're allowed to go out to sea, inverted commas. So that's us. Forgive me if this is a little bit sales pitchy. I didn't mean it to be, but I need to give a case study of us, what we've built, why we've built it, and then our certification journey. So that's the vessel we've built. That's down in the southwest approaches, just outside of Plymouth Sound. We are one of the vessels that were certified this year. She's a swath, small waterplane area twin hull, 14 metres long, 25 and a bit tons, seagoing displacement, and 9 metres beam. So she's a bit bigger than a lot of the USVs out there right now, but that's changing. Why did we go with this? So my background, I think you got a bit from the précis, it's nearly all military, and defence, as in a lot of tech cases, is a little bit ahead of the rest of, well, all other sectors in that they want to push ahead with doing stuff. The trope is dull, dangerous, and dirty. That's why defence has been trying to get uncrewed systems in, subsurface and surface, and in land as well, actually. Mine countermeasures, EOD, bomb disposal, that's pretty dull most of the time when you're trying to find stuff, and then when you do find stuff, it becomes dangerous quite quickly. So robots, great idea to use those. And absolutely the same in the maritime, mine countermeasures at sea, as well as bomb disposal ashore, is where autonomy has been used quite extensively in the past, and they're now at the point where they're being deployed operationally in the maritime space. That's where I've come from, and all of those lessons which I learned from trying to get that new kit over the line and operationalize it, I've joined my CEO in the company, who did exactly the same as the COO for a company called SeaKit, which was eventually bought by Fugro. So those USVs used in the commercial sense, his lessons and the problems that he identified were, broadly speaking, the same as the ones that I found. So we cobbled together and came up with this thing. I call it a pack mule. She's not pretty. She's quite small relative to the jobs that we're going to be asking her to do. But she'll deal with horrible conditions, and she'll take a hell of a lot of weight. So despite her being only 14 meters long, that moon pool, that Mission Bay rectangular moon pool you can see in the middle there, perfect shape for a 20-foot ISO container or two 10-footers. So that's pretty good utilitarian footprint, easy ISO twist lock fix for mechanical integration of any payload you like. We'll come on to some of those in a minute, the tons of use cases. But she'll take 6.5 tons in that middle of that moon pool, which is pretty good for a 14-meter boat. And she's got an endurance with the battery electric diesel hybrid powertrain, which we're integrating now. The basic maths, the physics says if we put just under 4,000 litres of diesel in those demi-hull tanks with a couple of gensets in there, 30 kV, the math says doing a survey speed of 4.5 knots, you're actually getting well over 70-odd days at sea, but we're not selling that. It's going to be a little bit lower. So it's the fuel efficiency and it's the mass. It's not just dull, dangerous, and dirty. Why do people want to get down this route? It's the scalability. I agree with Simon. I don't think this is going to be the death of everybody's job in the workboat industry, but I do think that the types and flavour of qualifications and jobs to operate this stuff will change. What does it offer? You're still going to need people to operate and manage this stuff. And if you've got one workboat out there, you're going to need the equivalent number for workboat crewed as you are for workboat uncrewed to operate and manage it and do its payload, sensor, recovery, whatever its task is. But the beauty of uncrewed systems is that you can scale them. So you'll still need people to operate them, but you'll need a smaller number of people to operate many, many more. And to build and operate those many, many more is going to be a hell of a lot cheaper. you're going to be able to do larger jobs more quickly and more cheaply, and arguably more safely too. The lessons that we picked up from the previous work that we'd done, my CEO and I, to develop this weird-looking thing, it was all about reliability and persistence at sea. So certainly where I've come from, my background, it's about little USVs or little autonomous underwater vehicles being launched from a mothership and then going off and doing some task and coming back. So launch and recovery from a mothership is one thing that had to be featured into that design, and relatively easily too, because there's nobody on board to catch the hook at the right time or to slip the bow line as you're going off. But the problem with that, and the problem with conventional monohulls and stuff, is it's pitching, rolling, yawing. If you've got people on board the boat and you're trying to deploy a heavy payload, an ROV, or a towed body, or a multi-beam echo, whatever it is you're trying to do, if you've got people on board and eyeballing it, you can pick the right moment. Or if you get a riding turn on a drum, something really easy, you can fix that, generally within a couple of hours or whatever. There's nobody on board that boat, that's game over, mission abort. That has been a perennial problem. So we've tried to give everything multiple redundancy systems in this boat. And the key thing about the hull form design, that swath form, is instead of pitching and rolling and yawing, if you know anything about it, I'm going to get hammered by all of the naval architects in the room, but as long as you've trimmed it right and designed it well, it will tend to heave rather than pitch, roll, and yaw. It gives a real stable platform. And if you're trying to deploy a sensor or a payload from the center of gravity in the middle of that moon pool down, you're deploying from the most stable position of an inherently stable platform. That's exactly what we've tried to do. And we didn't cut any aluminium before we got that extensively tested in the wave tanks at Wolfson Unit in the Uni of Southampton. And since then, we've gone to sea, and we've got some really compelling data, which hopefully I've chucked in. There you go, there's a bit. So there's our boat, 25 and a bit tons. There's a Serco Denham vessel down in Plymouth, 121 tons. It went out. This was significant wave height of about 1.5 meters, with the odd wave coming through at 2 meters plus. But just look at the accelerometer data there. The red is the Serco boat, is 120 odd tons, ours is 25. We're the blue accelerometer data. That's for for pitch only. But it's broadly speaking the same kind of ratio for pitch, roll, yaw, and heave as well. So the proof's in the pudding. If you can go out and not smash yourself, your boat, and your payload to pieces, you're going to be able to stay out there for longer. These are the kinds of use cases that we've magicked up. We make the boat, we don't make the sensor or the payload. So we're going to be partnering with companies that make things like ROVs, autonomous underwater vehicles, towed sonar of various flavors, or if you're doing border force, border protection, intelligence, surveillance, reconnaissance kind of stuff, then there's a load of other types of sensors that can go in there as well. Any task, basically, where you just need something to sit out offshore, handling good conditions and also handling horrible conditions, and do it really, really cheaply, and just listen or monitor, or when needed, deploy something to interrogate something. You could do it with a big conventional crewed vessel, and that will cost you X. Or you could do it with a bunch of these things which cost a fraction the build and a tiny fraction of the daily operating cost. And you're covering an entire area, e.g. North Sea, North Atlantic, or whatever it is you need to do. So for that kind of persistent presence, deployed up threat or whatever, that's exactly what this is designed to do, as well as conventional survey, ROV, light intervention stuff, which is what commercial USVs have been used for up till now. We were the first remotely operated uncrewed vessel to be certified under Workboat Code 3, Annex 1 and 2. 2 being the uncrewed bit, 1 being the hybrid or alternative propulsion systems, because we got battery propulsion vessel. This was a journey. Initially, before Workboat Code 3 came out, we were going to certify this under the MGN 664 innovative stuff. To do that, you've got to come up with a risk assessment and basically a bunch of evidence to say this is why you should be allowed to crack on and you're safe. So we were going to do that via the Lloyd's Register Unmanned Marine Systems Code, which it generates a bunch of evidence, but not recognized by the MCA, but it would give us the evidence to argue that we're safe to go under the old MGM 664 process. We were going down that route, and then Workboat Code 3 came in and said, we've got to shift target now. So we've had a bit of a round of things. The biggest problem, I would say, is that for certification, To be blunt, we, as the boat builder, don't really know what's in there and what we've got to do because stuff is subjective, whatever code you're reading. So we might think one thing, then your certifying authority might think another, and then the MCA thinks another. That's human. The certifying authorities, it was all new to them as well, and no one really had properly certified these things before. So it was a learning journey for all of us, I would argue, from the top all the way down to the bottom, I think it's probably fair to say. And as a result of that, it takes bloody ages, and it ain't cheap for the first one. We are really hoping it's going to be cheaper for the subsequent ones. I can chat a little bit more about that later on if you want. A couple of Gucci images of us and potential use cases. So deploying stuff for non-destructive testing, inspection, offshore wind farms. There's ROVs. There's AUVs. That's an interesting one. Autonomous underwater vehicles. They're actually all over the place, used in defense and also in the offshore commercial sector. And they are not certified or certifiable at all yet. There's no code rules for them. I'll bet you the moment one of them crashes into a gin palace, that will change quite quickly. She's actually built, she does exist. That was during her initial launch in Turnchapel, complete light ship, no payload in there. It was just for a bit of an initial leak test, trim and stability check. And there's her sat in the water. She's riding really high because there is no payload in her. So that moon pool in the middle, we've got to have either ballast or some sort of payload of circa 6 and a bit tons to get her to the seagoing trim condition. But it gives you a bit of perspective. You've got a little dude on the deck. Gives you a bit of size perspective. That's me, time up. And that is a 6.5 meter rib down there, moored up outboard of her. Bit of a canter through. I am available for questions later on, but I've got to catch a train at about 6:05. Thanks very much.
Great, thank you very much, John. So Jason. Jason comes as Managing Director and founder of Green Marine. With over 30 years' experience in the marine sector, he's responsible for leading the company's future growth. Green Marine has grown from a vessel owner operating company to a provider of turnkey solutions, subsea survey provider, along with a capable in-house team of engineers who have been commended for their success. Green Marine's main business is in the offshore wind sector, in which Green Marine has worked on most of the UK's wind farms. Green Marine has been the recent recipient of numerous national and international industry awards under the leadership of Jason. So thank you very much.
Yeah, thanks, Andy. I must admit, everybody, I was struggling with this topic. So autonomous vessels, USVs, AUVs, things like that. We're not a technology developer or operator of these vessels, so I was struggling a little bit when I was asked to join this panel. But I can go over the sort of benefits that we've seen since the introduction of these. We've been working with them for, I think 2019 was our first experience working with autonomous vessels. So I'll give a little bit of an overview of Green Marine for those that don't know us, and then some of the benefits that we've seen, and there is obviously challenges and certain concerns for our industry. So I formed the company in 2012. A little short timeline there. I'm not going to run through it all, but running up to expanding our fleet, expanding our team, and then in 2019 we started working with the likes of Fugro, Exocean, NOC, and deploying and looking after some of their devices, whether it be USVs and AUVs. So that's underwater little torpedo things that were shown in the previous presentation. So that's kind of developed quite a bit of business for us. And then 2025, we invested in additional survey equipment, and ROV equipment, and purchased another business that was long established. So that gave us some a bit more expertise in that subsea survey sector, and combining that with the latest technology, which includes a certain amount of autonomy as well. And I think I got a push to plug Siemens in that sort of deal. So Andrew and his team assisted us with the purchase of the equipment and also the additional business. So this overview of what we do currently with our vessels, and anything from cable burial, we're doing a lot of cable works this year on offshore wind farms, and then some of the subsea services, GVI, which is inspections, NDTs, asset integrity, so we've been doing subsea cleaning of devices and things like that, using the latest software and ROV equipment. And then we've got, as we know, we're a workboat operator, so autonomous. Are we autonomous vessel operator? Well, no, we're not. Will we be? Well, we'll see how the industry goes. I mean, we may be a client to purchase one of these systems in the future. As we know, like multicats, tugs, things like that, have got multiple operations going on, and I see certain aspects of it. You could make them autonomous, but to run the whole vessel would be quite a struggle because you have cranes going on, you've got different subcontractors, different devices. So I think a lot of our industry will probably never be autonomous, but certain aspects of it may be, such as navigating through certain fields and things like that. So yeah, I think there's opportunities as well as challenges there. So the drivers for autonomy, I mean, the other people on the panel know more about this than me, but I mean, I guess safety is one of the things. As I mentioned before, like a multi-cat or a turnkey service, what you're doing with multiple subcontractors and equipment on the deck of the boat, it's so dynamic. Things happen. There is, that there's got to be a method of change, stop the job. I think that to put autonomy into that would be quite risky. It's the repetitive jobs that maybe automation could come into, and maybe we could introduce that for transiting from A to B and such like, and giving crew some more rest and things like that. But I think what we've seen is autonomous vessels that are being introduced have got quite a large human element behind them as well. So we do feel that that the skills are transferable, because a lot of these vessels are, in the marine environment. They need a sort of mariner stamp on before they go to sea and things like that. And I think that there is opportunities for current employees and future employees that are in the industry. We've already started training some of our guys in operating subsea equipment, and actually more into sort of software and this crazy world that we live in with AI. I mean, AI is coming into everything at the moment. You hear it all over the place. So we are introducing that into the company, and how we can make some of our subsea vehicles more autonomous as well. I mentioned NOC as well, so we've been working for them for, I think, 4 or 5 years now, with Blue Ocean and some naval sort of AUVs, and also Fugro as well. So found that these USVs are needing sort of backup vessels for emergency recovery, for assistance and things like that. On the ROV side, on the subsea survey sector, we can use software now to predetermine routes, so the ROVs can fly a route, takes a bit of the stress and strain off the pilots, so that is easing their sort of attention span. They can set it and keep checking that it's going along a certain pipeline or a certain cable route. We found that latest software has been fantastic. We're looking now at implementing some software that will identify targets, so using AIs for identifying UXO and things like that. We're trying that at the moment, so that's a new service and a new, I suppose, opportunity I see for autonomy and using AI as well for assisting in operations. I think that for us to invest in USVs and things like that, I think we need a bit more technology development, a bit more proving, and the regulation, as I'm touching on. Their insurance, I had a brief discussion with the insurance guys here. I think it's they quite like it, because there's quite a opportunity for them to command quite a high premium with new technology, as we know that with new vessels as well. So, and I mentioned before, upskilling the crew. So we're doing ROV training with our existing crews. I think there's a bit of a switch in new people coming into the industry now. They don't want to get their hands dirty so much as some of us in the room and more experienced people. They're into technology. They pick up this software programs and operating this very high complex equipment very quickly. We've started training. We've had guys down at NOC getting them trained in the AUV sector, so downloading data, uploading data, changing the battery packs, recovering and deploying the subsea gliders, and we keep a stock of those in our facility in Orkney. I think it is a challenge, but I think there's opportunities there. I think for the seabed surveys and the mapping and things like that, it'll open up opportunities, certainly in the sort of short term, from boat operators, because we can provide a support service, whereas if it was like Fugro or some of the larger companies coming in with a very large offshore vessel, they don't really require any services from most people in the room here. So I think that's a good opportunity for working along with the autonomous sector. And that's it, really. That's what I could say. There's challenges, but there is opportunities as well. So that's it. Thanks.
That's great. Thank you very much, Jason. So as you've seen from the speakers, I guess the general theme is opportunity rather than challenge or constraint. And in order to explore that opportunity, Simon, I wondered if we could start with you, just to give us a flavour of the types of applications that you think USVs will serve, and perhaps an approximate timeline as to how you see that might roll out.
Yeah, sure. So I think, starting with the crawl, walk, run, fly kind of scenario, the first areas where we've seen USVs have been primarily in the survey and the seabed mapping, because effectively all you need is a PC to run a payload, right? You can remote into the PC, so you can do that remotely. Then you just need to control the boat remotely. So that's been, probably first and foremost the most popular kind of area that we've seen it. And I think that's the crawl. And then I think the walking and the running and the flying, that's in the slightly more developed areas like Aqua Ocean, where you've got surface assets deploying subsurface assets. So we're at a point where the first USVs are being certified that can deliver subsea assets. So that's the Fugro vessels and the Aquas. Okay, so that's happening now, but the commercial application of those is still a little way to go, because it's not until we get these vehicles in the field and hammer them and work them and put them through the rigorous conditions that they're going to experience in the North Sea that we're really going to see which bits shake and fall off and what needs to be fettled and tweaked with. And at that point, we'll have the confidence for operational execution. And one of the stumbling blocks we've had is tied to regulation, because we're not allowed out to go and do that. So that needs to change still in the development space. So I don't know, John, what your thoughts are on that commercial bit and in getting ready for commercial ops from the development piece.
The question is kind of, as you say, Simon, is what jobs are these vessels capable of, and what's the timeline for rollout, do you think? And obviously we've got, as you say, I think you've sort of said survey broadly, including deployment of subsea components, as well as just having a hydrographic survey device on the boat itself. Presumably defence. What other things do we think these vessels can do?
Well, the subsea delivery piece is one, but then I think also there's quite a lot in the met-ocean area. So far offshore, long endurance, I think that's a pretty good market, where we can, particularly when we look at floating offshore wind, it's getting further offshore, having vessels that can go out and do site assessments, long endurance without having to put manned boats out there. That's a good place. Certain types of guard duty, I think there's scope for, particularly if the vessels also have multi-beams bolted to them. If you had something circling a wind farm doing guard duty that can then go in and run a quick multi-beam if a jack-up drops a blade, for example, they're quite useful applications. So, I mean, I work mainly in the offshore wind sector, so those are the kind of things I foresee. And you've already mentioned defence, which is massive.
Yeah. Please share your thoughts, John.
Thanks. I already talked about I completely agree. The survey bit is and was the most logical first step. It is, as Simon says, relatively simple. You just have to worry about the boat itself and where that's going, and not worry about a completely disparate payload. And you're not trying to interfere with anything kinetically or otherwise. It's just the boat. But defence has, and this is British Royal Navy, has been playing with nested robotics, deploying an ROV from a surface vessel with nobody on board at all. And I talked about the use cases for EOD. So there's a survey task that happens. They did that first. They find all the bad stuff. And then, well, why can't we make the robot go and identify and then maybe neutralize the bad stuff too? They've been doing that now so it's been in like a lower tech readiness level now for about 10 years. And they've been operationalizing it now for about 3 years. So they're a step ahead. Other use, well, you've heard them all. Basically anything which requires a picket, or if you like, sitting out there, costing not very much, but able to respond really quickly. It could be a survey, go and find something that's gone missing, go and do an inspection or a bit of light intervention on something for us now, or it could be just sit there and listen because we want to know if any submarines are coming through this way, or if any strange surface vessels that are transmitting that they are this, but actually they are something completely different. If you haven't got the eyes in the open expanse, then you can't tell what's out there without something acting as a sensor, and that could be something static on the seabed, but then that needs to communicate. So your surface vessel connects to a rebro node for that. I'm getting more into the realm of defensy stuff, but the commercial utility is there too. To do that, to have that persistent presence offshore with crewed vessels that are able to withstand those horrible conditions costs a lot more than it would do for what we've developed.
And
Is
John,
that enough of an answer?
that's great, thank you. And you think that, speaking of defence, I presume that that's going to be a big business revenue stream, hopefully for the business, if not already. Are they working with SMEs and companies like yourselves and commercial technical expertise to bring what you're doing into their sphere, or is it kind of controlled? How's that working?
That's a huge question. There is a dawning realization that so if we're talking exclusively about defence, so there's a dawning realization that the old school primes, the BAEs and the Thaleses of the world, who make phenomenal kit, but gosh, you pay for it. But they don't do it quickly, and they won't build stuff unless there is a really explicit set of requirements. It must do all of these following things, and it, conform to these standards, and here's the budget. Then they'll build it. But if your customer can't write a requirement set because they don't know what they don't know, this is new stuff, right? And how do you join the dots and say what are autonomous systems, and what is a remotely operated uncrewed vessel capable of doing these days? If you can't articulate that because you don't know because it's new, then you can't write the requirement set, so then the big old defence primes don't build it. So you need gnarly little companies like mine to come up with these crazy little ideas, and hopefully we survive long enough that we can actually cross that chasm of death and build something, and we're crawling up the other side now as we speak.
So with Jason's language of opportunity, there is a lot of opportunity for crossover between commercial and defence with these types of
100%. It is, I think it said it on one of the slides, that most, in this environment where we're planning to operate, a lot of the use cases, the Venn circles between defence and commercial sector overlap hugely.
Yeah. Okay, so to then ask all of the panel, I've just listed some boat type / application requirements, and I just want to hear your views on whether you see it moving to autonomy or not. So I'll say tugs, for example. Do we see those being uncrewed? It's just yes, no's, by the way. No, I'm joking.
Yes, but quite a far step down the line compared to some other applications.
It's not for me. I don't think so.
Yeah.
I can't say no, but not within the next. I'm not a betting man. I'd say not within the next 10 years.
Okay. And I'm presumably similar. So the same, I guess, any form of towing, pushing, anchor handling, buoy handling, those kinds of things, probably not so soon. Is that the general flavour, we think?
I think so. I think there may be some technology improvements that could make some of these operations safer. So using some remote controls on board the deck of vessels, that could start, we could have assistive means, but I don't think it's going to be uncrewed.
Mm-hmm. I would agree. I mean, as I said, like using a multicat and things like that, or using a tug, there's so many dynamic things happening on the boat that I think it's too challenging. Just to pick up on what you said about remote operations, I was with a friend of mine at the weekend. He's on one of the most technologically advanced fishing vessels in the world. This is 86-meter vessel. They have, not autonomous, but they have winches on there, which several hundred tons of pull. And he was badly hurt in an accident. And the reason was because there was an operator operating a winch with a remote system that didn't know he was there. And very nearly killed him. Now, you've got to have that sense of reality and that sense of feeling. I mean, you've got to have eyes on everything. And, autonomy, or it should do it, but there is glitches and there's usually somebody behind it. And I think that even with some of the simple operations that USVs are doing at the moment, they have a rather large team just to do the simple tasks at the moment. And I guess that's got to be honed, but I do know that some operations we've been involved in have had about 6 times more people on the job than what we would have been doing with a workboat.
And I guess that rolls me, well, I would like to ask pilotage quickly, and then I want to come back to that. What about pilotage as a discussion point? Can we see us at some point not having to transfer someone between a little pilot boat and a ship?
Sorry, I have to explain that a little bit. Do you mean talking about? Are you talking about putting a pilot on board an uncrewed vessel, or are you suggesting that an uncrewed vessel could act as a pilot vessel?
No, as in the vessel itself, the ship itself, wouldn't need a pilot because of autonomous systems actually being able to take it into the port.
Great. Well, look, for vessels of our size, I'm going to play focusing on that for now, rather than larger ones. So the type of workboats that we've got, it will come down to the level of certification that the vessel's got and your local harbour authority's appetite and knowledge of what the regulations are. Even with certification now, so I mentioned earlier on that we're in Plymouth, and we moved down to Plymouth because geographically it's pretty handy. The infrastructure's there, and Turnchapel Wharf is a great place to site. But the harbour authorities were permissive long before you've got certification. As long as you can present a decent safety argument, you can go in and do stuff inside Plymouth Sound, which is great for the early stages of your trials and evaluation. But even with certification, you've still got to follow there's a new set published last month, set of local rules for Plymouth Harbour, which mandate stuff above and beyond the certification. I think it will be case by case. I don't think I can argue that writ large. I think it's going to be dependent on your level of certification, your safety argument, your tech readiness level, and the appetite of the harbour authority.
So you don't see it as a technical barrier, though. You see it as a regulatory.
Yes, I think that's right to say. I think that and we already are there, where your navigation systems are automated enough on crewed vessels. We are already there whereby the mission management and navigation control system for autonomous systems, and I'm talking autonomous systems now, not remotely operated, which is what we're all certifying to, they're already there. Colreg compliance stuff is, nobody's actually Colreg compliant. So when you go and meet the 20-odd USV manufacturers that Simon was talking about, oh, we're Colreg compliant with my magic software platform. None of them are yet, because they can't discern a sailing vessel under sail, or it's got a cone with apex downwards in it. They can't do that yet, so they're not actually really there yet, but they're near as damn it. They could do that. But we can't certify to that level yet. We can only certify remotely operated, so that's what we are. It literally is a dude in a rock with hands on sticks and levers, waypoint following once you get out to sea, but you're sat there watching everything. But we are already at the point where you could automate all that. So it's regulatory, but it's not. I'm not talking about MCA regulatory, I'm talking about local harbour authority appetite.
Yeah, I'll just add to that a little bit. I think entering port's a really dynamic environment, and there are too many variables. And I'm going to coin the old phrase, there is no substitute for experience. And there's an awful lot of autonomy in ML and learning that needs to be done to try and address that human element and that experience in those dynamic environments in close quarters. What we do at the moment is we take, we effectively do pilotage. We lead our USVs to open water, then hand over control to remote operation centres where there are no hazards in close proximity. The thought of taking that assistance away when coming into port is way down the line in my view.
And I guess this is part of Jason's theme of there's a lot of people involved actually in the journey. It's not just send that out and best of luck. There's a lot going on.
Yeah, there's tons going on. It's way more complex, and the more you start digging and the more you try and do and the more you try and get your asset to try and, the more dynamic you want it to be, the harder it gets. So the crawl and walk space is in that, okay, let's have a really well-defined concept of operations where we can put boundaries around our operation, and let's do that well and then grow from there. Okay, let's not overreach. But, I mean, Acura guys have proved us wrong time and time again. We saw the renders of the Acura Ocean vessel for years, and then one day it rocked up, So it can be done, and people are out there doing it.
Shall we, any questions from the audience, please?
Don't be shy.
Good afternoon. This is a question aimed more at Simon and John. Will the vessels have a cyber resilience notation? And if they do, what is the risk of cyber attack?
Okay, I'll go first. So, yeah, there is a risk with anything where you're playing with RF or SATCOM. We go over the horizon. We purport that we can pilot the vessel over the horizon, out of sight of the rock. So to do that, you've got to have the communications bearers, and there's always and if you're within line of sight, then you've got other alternative means, RF. Yeah, there's a risk. We have to demonstrate a degree of cyber resilience to be certified. That's what's written in the Workboat Code 3. And then I talked a minute ago about the subjectiveness of what the builder might think versus what the certifying authority might think versus what the MCA might think. So we had to satisfy the MCA Workboat Code 3 and also Lloyd's Register. And to do that, we had to get third-party auditors in to do pen tests and try and hack us. So we're mandated by the MCA to go through levels of assurance and interrogation. And as well as that assurance, we have to provide a means of fallback and redundancy if something was to go wrong. But that can happen with all vessels that rely on digital tech.
Yeah, that's what I was going to say. Is this a cybersecurity threat any greater than a manned vessel?
I think it's a different flavour of threat because you've got nobody on board. But the idea would be that because you are operating from a remote operating centre, we're certifying uncrewed, remotely operated and not autonomous systems, not yet. So that means that in theory, you should spot pretty quickly, as you would on a bridge. If you've got something not quite right with your systems on board, you'd be able to spot that, hopefully, within a reasonable amount of time. It shouldn't be any different if you're in the remote operations centre. Shouldn't be. Does that answer your question?
Anyone else?
Yeah, I agree. I just want to add to that. There's the only thing you'll find with USVs that may be different to traditional vessels in terms of security and cybersecurity is that there are a number of different ways that you can operate different USVs. So, for example, a control system, the actual interface where you can point on a chart and tell your USV to go to that point, it could be hosted in a cloud. You know, you might have to go to log on to then, and then the server could be in another country, or you could be going more directly. You could have servers in an office that you're in and you're next to it. So how is the office protected? So these different comms links present different points of weakness for potential attack.
Simon, this might be a stupid question, but if it was on Amazon Web Services and it went down, what happens then? Is that a thing?
Yeah, so redundancy is what you need. So it starts on the USV. So if you've got, this is a really good point. So when Starlink came along, we went from, Iridium Certus links where we get one frame every 4 seconds sent to us in the rock. And then Starlink comes along and we're in the wind farm and we're remote in our remote operation center and we can now see the blades turning. That's the kind of difference. But what happens then when Starlink does go down? Okay, our redundancy, there is no equivalent to that. So, that raises so many questions about our operators as well. So those of us that were operating USVs on the 700 vessel link, we got used to doing it one frame every 4 seconds and doing it safely. But for new operators that have never, had to work without Starlink, that poses different threats again. So yeah, redundancy is really important, and we need more backups.
Any more?
Thank you. Just to bring in a bit of a Workboat 3 view on it. So as well as the redundancy, there's very much the need within the annex to look at how can your vessel fall back into a safe state? What might that safe state be dependent on the pressure it's experiencing? And then also, John was saying earlier about the different flavours of risk for a manned vessel versus an unmanned vessel. So, for example, if you're talking about an unmanned vessel, you'd need a requirement there to make sure that someone cannot log in to control that vessel that doesn't have appropriate authorization, or you can't have someone thinking that they're doing the correct thing and logging in to be the remote operator for that vessel when someone else is already in control and causing a potential incident. So it's just looking at what those unique challenges are for remotely operated vessels versus the risk that anyone with a workboat that's connected in any way, it could be as simple as someone's looking at some systems and they've clicked a funny link on their emails. So it's that level of awareness, but it's the different hats between manned and unmanned. The risks are significantly different.
Just in case, because I just realised that people are sat here and this might be completely new to a lot of people, and I struggled with this, not that long ago. But the remote operating centre, we've built one vessel so far. We've commenced to build a vessel 2, and we will be selling vessels, but we'll also be offering services, data as a service or whatever it is that people are after, and we'll pilot them. So at the moment, I've got one main rock, which has got like a Darth Vader's bathroom of screens and stuff in it, and that's how I operate the platform. I've also got a backup rock, part of the process of getting certified. If I lose power and internet connection and whatever other redundancies I've got inside that remote operating center, I can bail out and go and flash up my other fallback rock and still operate that vessel within a very short window of time. But because it is all over the wide area networks, the internet, there are other companies that are operating their USVs. They're handing over from watchkeeper to watchkeeper, literally the other end of the country. So one rock could be in some person's study and they're operating that little USV, and then they come to the end of their watch, they dial up and say, here it is, this is what it's doing, can you see it, yep, handing over to you now, you have the boat or you have the ship, and then they're operating it from that other rock. That's a bit to get your head around, isn't it, if you're not familiar with it? So there's the flavour of risk we're talking about, and that all needs to have rules around it.
Yeah, quickly, Jason, thank you.
Can I just a quick one on that? So redundancies and safety. So I guess this is for Esme, MCA. You know, on a time, I guess I can't hold you to this, but if you've got any idea, like even if USV is coded under Workboat Code 3 or under certain coding, will they be allowed to go to sea without any backup or emergency vessel standby, a manned standby?
So there's not a requirement within the code of practice for a guard vessel or a standby vessel. It might be a choice of the vessel owner or operator as part of some of the mitigations and risk assessments they put in place to do that. So if they chose to go down that path, that would be their decision. In terms of what redundancies you do or do not have, there are some within the code of practice that are specifically mandated, but then there are other areas that you might then address through a risk assessment and say, I've not got that specific thing, but I've reduced that to a LARP by doing these things instead. So it gives that slightly more goals-based technique than previous versions of the Workboat Code was written to.
Thanks very much, Esme. Unfortunately, that's our time. Yeah, the guys are... John's got to go home quite soon, I think, but everyone else is around. Please do ask them more questions. Thank you very much for joining. Our next session will take place in Rotterdam on the 26th of March 2025. It's a SeaWork event. Please put the date in your diary. That's the 26th of March 2026.